Hi guys. In this video we're actually going to graph cosecant and secant functions. Now if you ever look at a cosecant and secant function, it's actually pretty confusing at times. You look at it and you're like, wait, how am I even supposed to do this? But it's pretty simple. In order to graph cosecant and secant functions, you have to know the reciprocals. Hopefully you've been taught that anytime that you want to graph cosecant, well, you can't work with cosecant. You actually have to work with sine, because cosecant of x is equal to 1 over sine. Reason why we always do sine in order to do cosecant. And with secant, we know that secant of x is equal to 1 over cosine. So you always do cosine in order to do secant. Knowing that's going to be pretty much your lifesaver in order to graph these. So we're actually going to go ahead and do an example. Now I do encourage you that if you haven't seen my sine and cosine videos to watch them, because you need to know how to graph sine and cosine in order to graph cosecant and secant. Now let's go ahead and get started. Well, the first thing I'll notice is y equals 4 cosecant 2x. I don't know how to graph that, nor do I want to, but I do know how to work with its reciprocal, which is sine. So I'm going to go ahead and graph 4 sine 2x. Now if you remember from the previous video, the first step is you always have to figure out your a. Well, the a is a number in front of sine. So in this case, a is equal to 4. Then the next step is you have to figure out your period. And your period is determined by 2 pi over whatever your b is. 2 pi over 2, which simplifies to just give you pi. So that means the length of that one cycle, that one period, is going to be pi. The next step is you have to figure out your points. And remember, because there's 4 spaces in your graph, you're going to always divide your period by 4. I got pi, so divided by 4 gives you pi over 4. Now, because we're doing the same exact examples from the last the last video, I went ahead and just used that graph. So we're going to go ahead and figure out how we got the points. Remember that the reason why I go up to 4 and down to negative 4 is because my a equals 4. My period is pi, which makes sense because look how far I go, pi. My points, my first one's pi over 4, and the next one's pi over 4 times 2, pi over 4 times 3, and pi over 4 times 4, which would make sense because that's how long it works. And then to find the negative side, just keep all the positives except make them negative. And you got to remember, sine starts from the center, goes up to the top, middle, down, middle. And then it's the same thing on the other side. Middle, down, middle, up, middle. It's a constant pattern. Now, how to graph cosecant? You got to remember, your goal isn't to graph cosecant at all. So your goal isn't to graph sine, your goal is to graph cosecant. So once you do sine, everywhere it crosses this x-axis, you have to draw a vertical asymptote. That's the first step. After you graph sine, everywhere you see that your graph crosses the x-axis, draw a vertical asymptote. Your next step is to draw parabolas. Anywhere you see a max or a min determined by your amplitude, you're going to create a parabola. Now the unique thing about the parabola is it has to go through that point, the max or the min point. Same thing on this side. And same thing over here. Now, the graph of 4 cosecant 2x is everything you see in the green. All the parabolas on the max and the mins of 4 sine 2x is your graph. So anywhere you see a parabola, that's the graph. And this, if you have a pencil, your teacher probably doesn't want you to put 2 graphs, so you want to go ahead and actually put, with your eraser, put spaces around it, so that you know that's not your actual graph, and you only have the part in the green. But in order to graph cosecant, you have to be able to graph sine. Anywhere you see an x-intercept, draw vertical asymptotes all around them, and then your max and your mins, draw parabolas. Okay? So let's do one more. Well, in the last video, we actually went ahead and graphed 3 secant 2x. But actually we didn't. What we did graph was y equals to 3 cosine pi x. And then once we graphed that one, we had to figure out what's our a, what's our period, what's our points. Well, remember, the a is a number in front of cosine, so your a is equal to 3. Your period are 2 pi over your b, which is the number in front of x, which is pi. Simplify them, gives you 2. The next step is you have to figure out the points, and you're going to take your period that you have, which is 2, and divide it by 4 because it's 4 spaces, which gives you a half. So because it's the same exact one that we did on the last video, I went ahead and kept it. Going through it again. Your A is 3, so that's the reason why I go up to 3. Your period is 2, so that's the reason why it goes all the way up to 2. Your points is determined by 1/2. First point, 1/2 times 1, 1/2 times 2, 1/2 times 3, 1/2 times 4. I wanted the negative side, so I just made all these points negative. And you got to remember, cosine looks like a cup. So because it looks like a cup, I start from the top, I go down with more of a U shape, and then the same thing on the negative side. But remember, we're not graphing cosine, we're graphing secant. So that means the same exact rules that you use for sine. Anywhere you see your graph crosses the x-axis, what are we going to draw? Vertical asymptotes. So draw all of your vertical asymptotes anywhere you see that it crosses the x-axis. Okay, so hopefully you have all those VAs anywhere you see that it crosses the x-axis, and you want to be careful because sometimes we're not thinking and we draw these where the max and the mins occur. You have to remember it always happens where your vertical asymptotes are. And then your last step, is just to figure out wherever you have a max and a min, draw a U. Wherever you have a max and a min, draw a parabola. So I have a min here, so I know I'm going to do a parabola here. Remember, it has to touch that actual max and min point determined by the amplitude. Same thing over here. Anywhere you see a max and min. And the last part is, well, what about here? I kind of have like a half of a hill, half of a max. Well, I'm going to draw a half of a parabola. Now you have to remember that it always goes this way because it always goes towards your VA. Don't draw it over here because there's no graph over here. It goes towards your VA. And then lastly over here, your VA is over here. So draw it to the VA. And you got to remember, my graph isn't the stuff in the inside. Well, my graph is all the green parabolas. But in order to graph secant, I have to be able to graph cosine, which is what's in the black, and then everywhere you see an x-intercept, draw VA, and then draw parabolas, everywhere you see a max and a min. So in order for you guys to be really great at being able to draw cosecant and secant functions, you have to know this one rule. Anytime you're going to graph cosecant, you have to graph sine. Anytime you graph secant, you graph cosine, and then draw the VAs where the x-intercepts are, and then draw parabolas. Thanks for watching, guys. Hope it helped.